Hello, this is Nitin Dahad with the Times. I'm here at the University of Malta Engineering Research and Innovation Lab with the founders of a company which is about to spin out called ICECAP. And I have Andre Micallef, who's a CTO and founder of the company, and Thomas Gallo, and he's the CEO. Thomas and Andre, hello, how are you?
How are you doing, Nitin? Nice to meet you.
Let's start with you, Thomas. So tell us a little bit about what the company is and what it does. And you're just in the process of incorporation. It's based on 4 years of research. And we'll go to that in a few minutes. But tell us a little bit about the company.
Yeah, so we're really excited now to be able to spin out thanks to our research efforts. Our research has been on thermoelectric cooling, Peltier cooling. Peltiers are used quite a bit in industry and research, but we found that when you want to create large temperature differences, right, there's a real opportunity to create solid-state compact solutions that are also precise and reliable. But especially multi-stage cooling systems tend to suffer a bit from performance issues when it comes to power efficiency. And this is something we came across in our own research, our own devices, our own portable products. So we said, how can we you still get all the great things about multi-stage thermoelectric cooling using off-the-shelf products, but really push the efficiency into something that's not only good, but great, right? So we have some innovations on how we control and optimize these multi-stage Peltier systems, getting optimizations, efficiencies of 20% above and beyond other days. So we can get those really precise temperature cooling for really precise components or for even portable products.
Okay, let's put some context to that, because what you're doing is you're enabling cooling in things like portable electronics, and this came from a sort of camera project that you were doing, but also data centers, specifically I think you said things like optics, photonics manufacturing, and where temperature sensitivity, the wavelength is very sensitive to temperature, so I think being able to control at, say, -5 or whatever is quite important. Is that right?
Yes, of course, especially in laser diodes, photonics, and especially medical equipment, you really need to keep some electric components and sensors at a very specific temperature, or else you lose the characteristics or performance you're looking for. And that's often where Peltiers are great, because they can be very small, from micro to even larger temperature differences. So we're trying to get into that in terms of providing not only efficiency, but also precision that you'd need, not only for portable products, but also looking at manufacturing and testing, for example, characterization as well of materials and sensors. There's a lot of work being done now that we're starting to get into more advanced manufacturing, right? Everywhere we go, there's more advances. We need something that's more precise, more controlled, more accurate. And that's where we believe anyway, that thermoelectric cooling has the biggest potential.
Now, again, Peltier has been used widespread throughout history, I guess, but the point you're doing is you're making it controllable in terms of that temperature stack, thermal characteristic. Is that right?
Yeah, so you can use just a single Peltier, and people use it all the time, but you're really limited to how large of a temperature difference you can achieve from ambient, for example. And people then stack them up on top of each other to create multi-stage systems, but they're relatively rudimentary in how they're used. You're not allowed so much capability or customization of how it's operating between the different stages. And that's where we're doing things a little bit differently, right? We're adding more control and more optimization to the system so that we can really set exactly how we want the entire multi-stack system to operate. You mentioned before the camera, for example. And that's where we came from in terms of that. We had another project. We're developing a high-speed camera for scientific applications. And we needed to cool its CMOS image sensor, like I mentioned, a particular sensitive electronic component, to a temperature where it's, at the time, not sensitive to dark current, for example, which is very much...
You have an example over there, don't you? Maybe you can pick one up. Yeah.
So this was the camera prototype we had a couple of years ago. We were exploring high-speed imagery, and we needed to cool the CMOS image sensor to get the performance we needed. And we looked at Peltiers. It's already used by some other manufacturers and competition. But when you wanted to create the large temperature difference we needed, and using, in that time, 2 Peltiers, we found that it was consuming relatively speaking to the rest of the system, a lot of the power, right? Almost 60% of the power consumption was just from cooling the image sensor. So that's where this all came about, where we felt like we could innovate that space of Peltier cooling by optimizing how it's being done and bringing something else to market.
Now, you've got 2 US patents just granted.
Yeah.
What are they for?
So we have one US patent on the actual control method and optimization for multi-stack systems, providing not only the control method, but how we optimize. And the other is how do you mount these multi-stage systems to a PCB, for example, because that's already an engineering challenge in itself, right? It's an awkward form factor to begin with. How do you mount that in an efficient way onto a PCB to cool, for example, a sensor or some IC, or now we see there's a much larger investment being made in AI chips or heterogeneous setups or chiplets, where okay, we want to keep this chip at a very specific temperature. Let's mount this cooling system to it, but that presents its own engineering challenge.
We'll talk about ROI in a minute, but let's just go a little bit to Andre, a little bit of the background, and tell us a little bit about how you came to this where you are.
So, as Thomas said earlier, we had a big problem on our hands. We had an image sensor, which was very high performance, and it, given that it's high performance and you have a lot of frames going on, you have a very small exposure for each frame. And that means that any noise will now have a significantly greater effect on the quality of the image. So we had to cool the sensor down to minus 20 degrees. And, we're scratching our heads, how are we going to do this without actually, draining the battery in an hour's time? And by stacking these Peltiers, we noticed that even if the environmental conditions change or if the model isn't accurate, the power consumption and the control would derate and go, it wouldn't be optimal. So first and foremost, we said, how about we control each stage separately, and this control system would then automatically assign a different temperature apportionment to each Peltier. And that automatically improve the efficiency by quite a lot. It also includes hardware in the loop, because then the system would automate the whole process, and the camera would just get the best efficiency automatically. Then, in addition to that, as Thomas mentioned earlier, the second problem was thermally isolating the sensor. If the sensor, for example, develops 5 watts, then you would have another 10 watts as thermal leakage from outside. So by mounting these Peltiers on top of the sensor, then we would create another problem, because isolating them would create another problem. So we use this a system of guard rings, so that we wick away the heat as much as possible from the sensor, and that improved efficiencies by another 10%. And that's another patent, actually. And in conjunction, we actually improved the efficiency of a portable product, which in this case would be a camera, by a factor of 20 to 30%, which is quite
Okay.
a lot.
Now let's come to what you're going to be able to deliver to customers, because at the end of the day, right now you're 3 people. You've got 400k euros funding at the moment in terms of grants and research and grants. But now you're looking to commercialize and raise money. You've got public money up to 100k, and then you're looking for private investment. What are you going to offer? What's the customer going to get?
So we're developing a suite of products that we're looking to not only complement our IP, but where we can deliver as much value to the customers as possible using IP. So for example, our first flagship product is actually our controller.
Yes.
It's an off-the-shelf controller that will allow our customers to set up these setups we're talking about. So these multi-stage, cooling setups. We're providing.
So this is one here.
Yeah, so that's actually one that's sort of demo setup. So let's say you wanted to create your own setup in a lab or in a manufacturing environment, and you wanted to cool whatever payload. That's an example of how you'd use our controller, including our UI and telemetry, to not only create the setup, but also then track it, obtain data, and as well optimize it using our control method. So apart from these products, we'll also be hoping to complement it with other complementary thermal management products. For example, even in the future, we'll be looking at custom thermoelectric stacks that are much more compatible with our products, and also services and application-specific products. So what I mean by application-specific products is leveraging our IP to provide an extra edge of improvement on already existing solutions where Peltiers are being used. So we're looking at thermal cycling, for example, in manufacturing or in characterization. We're also considering cold chain transportation that could really leverage Peltiers to create not only precise but accurate and reliable cooling for
cold chain is actually quite critical because you're transporting medicines which have to be kept at specific temperatures, like -5 degrees. What you're saying is, with being able to precisely control it, you can guarantee through that certification that this will be at -5 throughout its journey. Is that right?
Yeah, not just medicines, but even in life sciences, they have a huge problem where they want to transport, cell samples and cultures. They just ship them off in a box sometimes with dry ice and pray for the best. But that's not really the best solution, right? We can provide an actual controlled and monitored solution on top of that actually allows you to...
Even semiconductor wafers, I think, they have to be controlled environment. So I think, it comes into many different areas, I guess.
Exactly. And since it's solid state cooling, you're not worried about refrigerants or any of these things.
So what's your big challenge, and who are your competitors, or is that something you're still sort of working on because you're still very young?
No, we're still very much in the birth of the company, but challenges will definitely be scaling are not only our designs but our operations. Garnering investment is always a challenge, but we're very hopeful in the capabilities we're able to provide to our customers, and we're very excited in how we'll be able to apply it, maybe with meeting new partners. We're now going up to Thermal Management Expo in November, hopefully to meet with new partners or to be present.
Where are the key markets that you're looking at the moment in terms of geographies, or have you identified areas? Have you got in your business planning?
So we're mainly focused now on the EU and the US,
okay.
Especially high value added manufacturing and R&D laboratories to begin with.
Okay.
But so why those? They're markets we can specifically target and hopefully cater exactly to their needs and provide them with value on top of what's already available. But as we continue to grow, hopefully, especially with the products I mentioned earlier, we'll be able to expand a bit more and scale the markets a bit to a larger addressable markets, right? More than just specific use cases, for example.
Why did you get involved as a CEO?
This history is that I was a researcher here at the university, and
you liked Andre?
It could be.
In terms of his work, yeah.
Of course, just purely his. I was a researcher here, originally working on the cameras, actually the FPGAs side of things. So I have an electronics engineering background, but we saw this opportunity, and I was interested in seeing how can we actually take this not just from an engineering venture, but actually to a business venture. So it's not only a learning curve for Andre, but also a learning curve for me as we go along. That's provided me is a very intimate knowledge of the technology, right? So I'm very much, I know exactly what went into the development. I know exactly what the capabilities are. So I'm hoping to be able to deliver the value exactly where we've witnessed ourselves.
And I see a number of boards which are sort of looking to ship, the controller boards. So has there been any early feedback from potential customers?
Yeah, so we're shipping some samples, hopefully by the end of the year, to get some initial feedback on the features, but also the usability of our products. And we're exploring also extra other leads where this is just one iteration of the controller, but there are other variations or permutations you can make different for different markets or different industries that maybe. So for example, this one can support up to 4 stages in the stack. Not everyone might need that. Some people might just need 2 or 3, depending on the temperature difference you're trying to achieve. And that's something we're learning as we go along, right? Depending.
So you characterize and make sure that people can get different modules to get those specific endpoints.
We have some. We're currently in discussion with some partners as well who do the thermoelectric manufacturing themselves, so the actual manufacturing of the modules, so that if we can also provide a full solution or modules that are very much compatible with what we're offering, that's something we think is very crucial.
Well, Thomas and Andre, thank you very much. Good luck.
Thank you very much.
Thank you.